just want to try to merge two lessons, two Zoom lessons. Like I want to take that group, if they can come this side. I don't know if they're gonna join us, but if we can have two more people, we'll be fine because everyone needs this lesson of functions.
Simplified are a set of guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Okay. Someone is asking for a passcode. Right, I think it's only 1% joining us and then we are good to go. Musiri, do you know how to speak Chinese?
Chinese? No, I don't.
You don't?
Mm.
We have someone who knows how to speak Chinese here, and her name is Shi Wang.
Does she know how to speak Korean?
Like, I think it's okay. Is it Korean? Is it Shi Wang? Is it Korean?
Yuang, yeah, it's Korean,
It's Korean.
but I'm still in the process of learning.
Yes, I'm just fascinated by this man, Shi Wang. So by the way, her name is Hope. So Shi Wang is Hope in Korean. Shi Wang. Find out, find out for me. Please find out for me in Korean when you are busy learning there. What is Simpiwe, eh?
Okay.
I want to update my name and put it in Korean then. But anyway, okay, back to the story. So guys, today the idea was let's go through functions because everyone struggles from functions, but it's more or less same thing repeatedly. Like whenever we face this problem of functions, it would be something which we already know or we've seen before. Look at this question that I selected. I selected this one because it is the simplest. The reason why I feel like it's the simplest is because the turning point is not that much complicated. Now, for all of us we are here, our level of this mathematics thing is not equal. I didn't choose this group based on any grade. I chose this group based on the fact that functions, they start to be a problem from grade 1 up until grade 12 for everyone. So I decided, you know what? Let's take a step back and see how can we simplify some of the things. But I want you to remind you something. Remember our concept that we've been following lately, Corey. Every problem that you have in mathematics or physics, it is about the diagram that matters. Every other thing is just information that supports the diagram. And the questions are always about the diagram. So everything, since it's about the diagram, regardless of what the questions want, when you must always make sure before I attempt any question, let me give myself time to bond with the diagram. By bonding with the diagram, I mean to look through the diagram, try to pick up some things that you would say to yourself before you even answer the question. Like look at the diagram and say, this diagram, I've seen it before. Last time I saw this diagram, they wanted x-intercept. Can I find x-intercepts on this diagram? Yes, no, maybe. This looks like a straight line. And straight line, I know it's in the form of f of x is equals to mx plus c, because those things you believe you could have learned them in grade 9 or grade 8. But even if you are still struggling, this is the moment to can still practice so you are ready by the moment you are supposed to be writing a test or something, because that's the whole point of this training. So back to the diagram. And then you like, what's happening in the diagram? So what's happening in the diagram? We see two functions. We're gonna go through the question, what they say. So this question that I selected is just question 5 of a random past paper. So here's the story. The diagram shows the graph of g of x is equals to ax squared plus q. And it also shows f of x is equals to fx plus c. Great. Two functions. One is this one is this one. Depending on your skill of mathematics, you should be able to tell, Hori, between the two graphs, which one represent which function. But before you stress yourself, it is labeled on the diagram which graph is which. So look at this. G of x is ax squared plus q. Here is g. They are telling you that the curve of g is represented by that. So that one represents that function for g. This part, let me pause and ask, do we all understand, or should we go back to how does it come to be like that? Or let me put it like this. Is there anyone who doesn't understand why do we say g, this g of x is represented by that curve? Let me remove the color and you look at it as blank as it is. Is there anyone who doesn't understand why we say g is that? You don't understand, ne?
Yeah, because there's also F there, so
But
man.
f,
Mm.
oh, that high is giving me a hint or you figured it out, ne? So the f represents the straight line. So f
Okay.
x plus c. So f is here. So the graph that represents f is the one that is, so the way they are making it easy for you, they label the graph next to the actual, like they tell you g is next to the shape of g and straight line is next to the shape of straight line. So in this regard, let me actually use different colors to make it make sense. In this regard, this is what's happening. You have two graphs in one, you have two graphs in one Cartesian plane. So you have a straight line, y is equals to mx plus c, because we know that that's the standard form of a straight line, right? And then you have the curve, the red one. There we go. There we go. But normally, at some instance, it would be you who had to draw this graph, who has to draw these graphs yourself, right? Like you would have a function and they say, draw these two graphs in plane. I'm sure you've seen such questions, right? So in this regard, you have two that are already drawn for you. They are there. But another way that I want us to, like, even if they didn't give you the name of saying this is G and this is F, it is our responsibility as mathematics students to know, for naturally, this type of function give me what? Because for instance, you are confident, for the straight line, it's far much simpler because you are used to it. F of x is mx plus c. You know that's a straight line. Hence, you are even confident to see f being a straight line. But that is a quadratic function. So f of x, this is the same as ax squared plus bx. No, I'm talking about g of x. Sorry. Let me scrap that. G of x is in the shape of a quadratic function. So g of x looks something like g of x is equals to, it was supposed to be ax squared plus bx plus c. And we say this is the general formula of a quadratic function. But in this regard, our given g of x, just g of x is equals to ax squared plus q. The reason why it doesn't look like our actual, the reason why it looked like we can't compare this with that, it would be because the value of b on this one is 0, such that if we were to write it perfect to make it similar, it was supposed to be ax squared plus 0x plus q, such that we would say, oh, a is equals to a. A is equals to a. B is equals to 0. And C is equals to what? Anyone?
Q.
Q. So we are matching based on how the quadratic is supposed to be. So in terms of a quadratic function, it was supposed to be like that g of x that we're given. It's just that the value of b is 0, unfortunately. So since it's 0, that's why they are not showing it there, because there's no need to write 0x. But if we put it in order of our understanding, this represents that, this would represent that, this would represent that, to show that is a quadratic function. And we know that ideally, a quadratic function would look like something like g of x would be, say, maybe 2x squared minus 3x plus 9, maybe. That's why I'm saying some of us would know how to draw this graph, finding the x-intercepts, y-intercepts, and a turning point. When you draw the graph, it's going to look similar to this. So now this time around, they gave you the graph, meaning you have to reverse from the graph. You must show how the equation of the graph looked like before they drew the graph. That's why they didn't give us the value of A. They didn't give us the value of Q. Also on the straight line, they didn't give us the value of M. They didn't give us the value of C. So clearly, we know that the questions will be about us finding those values of A, Q, M, C, and any other thing that the question will ask us. Now, if this question was to come out today in an exam and then they say to you, should you get this correct, you have passed mathematics, how many of us are going to the next grade? One year to say I can represent my well, but anyway, let me pause from here. We're gonna come back here. Yes. Oh, Jade, you would, ne?
Oh, Jane, you are.
Oh,
Yeah, I think so.
you would. Okay. Okay. We'll go back there. But just for a quick revision, for those who remember, we'll go back to that one. We are still. I'm just trying to say, for those who don't remember quadratic function, I'm gonna do one quickly, where we're gonna just plot 1G quickly, just to revise how it goes about what is expected from the entire scenario. So we're just gonna create one simplest one, and then we plot it amongst ourselves, and then we see. So the simplest one I can get would be, let me quickly cook it first. Okay, suppose we have f of x, or let me use g of x so it can be similar. Suppose we have g of x is equals to x squared minus, or we say plus x minus 6. Suppose we have this, and we have to plot the graph. I'm going to do it as quickly as I can because I know most of you know this. It's just a matter of revision. So first of all, we have to find, okay, let me say, let x to be 0 to find the y-intercept or y-axis. So g of 0, where there's x, I put 0. 0 squared plus 0 minus 6. Therefore, we just know that y will be minus 6. Happy?
Mm.
Happy.
Yeah.
I will then let y to be 0 in order to find the x-intercepts. And then to find the x-intercepts, I would say 0, because remember, g of x is the same as y, so now I'm letting it to be 0. So therefore, I would have 0 is equals to x squared plus x minus 6, which makes x squared plus x minus 6 to be equals to 0 if I write it like this, because we used to solving from the left in most cases. So if I factorize this, I would have that x and x, 3 and 2, positive and negative, meaning x will be positive 2 or x will be negative 3. And for a quadratic, we expect two values of x because it's x squared. It's a quadratic, right? And then after this, you may feel like you are done, but you are not really done, because in your Cartesian plane, the Cartesian plane won't be accurate, ne? Mara in your Cartesian plane, you can put in your values. Y is minus 6. Suppose minus 6 is somewhere here. X is positive 2. Suppose positive 2 may be somewhere here. And minus 3. Suppose minus 3 may be somewhere here. I've seen a lot of students. Let me let me give you a hint. Let me pause. Look at the structure that we have. Do you see the structure that we have, the way it goes?
Mm.
It goes like this. I'm talking about the curve that is similar to the one we are drawing. And then it crosses right here on this line. And then it goes like that. And then I've seen a lot of students who do the same. So in this graph, you get the y-intercept, and then you get both your x and your y-intercept. I've seen a lot of students who went and say, okay, I know this thing. I'm a master. And they do that. And trust me, this looks similar, because if you look at the structure, it's passing the very same way this one is passing, isn't it?
Mm.
Who's gonna judge you if you write it like this and you say you are done? Who will judge you? Only me. Okay, Mina, I won't judge you, because I always say you have all the rights to be wrong. I will correct
Mm.
you. The person who will judge you, we all know. We all know. The ones who are responsible for the tests and everything, who was like the other side. So those ones, hey. So it looks correct, yes, but it's not. Why? What's missing? You have to determine the turning point. And I will explain why the turning point on the other side ends up having that scenario that it has. So this graph doesn't always turn on the y-axis. Not always. It depends on the special event. So let's go back here and find where should we turn our graph. So meaning this one is clearly incorrect. So if we were to do it our own way, we'd then say, okay, fine. Since this is incorrect, let's determine the actual part where this graph should turn. So I'm going to leave our values as they are because we have to use these values anyway. But we just have to make sure that this graph, it has to turn properly. It doesn't just turn there. So I'm going to create a space here to find our turning point. So to find our turning point, we say for turning point, there are two ways to find your turning point. For those who enjoyed that lesson of completing a square, you can complete a square for this one and write it in vertex form. Do you remember? If you write it in vertex form, you would write it in the form of g of x is equals to a into x plus or minus p squared plus or minus q. You would write it in vertex form like this. So you know that your turning point, you will take it from here. But that's another story. We don't have time to complete the square now. So to find a turning point, I'm getting a turning point is in the form of x and y. So to get your turning point, for the x part, the formula is x is equals to minus b over 2a. That's how you find the x part of the turning point. X is equals to minus b over 2a. And then whatever value you get from here, you're going to substitute it there. That's why if I was to put it properly, I would say to find the turning point for this, it would be x is equals to b over 2a into g of b over 2a. Do you understand what I'm trying to say here? Let me pause for a minute. You have all the rights to say, I don't understand if you don't. So explain it properly. This is your powerful formula for finding a turning point. So x of minus b over a, which b and which a? That b and that a is from the fact that generally, remember, g of x was supposed to be and then we know that generally g of x was supposed to be ax squared plus bx plus c. So that's the a and the b and the c. So in our given equation there, we can see that a is equals to 1. B is equals to 1. And C is equals to minus 6. Does everyone agree from this given function of ours, the one I just gave now?
Yes.
Sure. So now that we agree, then x will be minus, if b is 1, I'm going to put 1, there's b over 2, 1 where there's a. So x is 1 over 2 in terms of our turning point. So where there's x for the turning point, I put 1 over 2. Now I need to find the g part of it. The g part of it is g of whatever answer I found on x. So g of whatever answer I find here. So I substitute into that. I don't know where can I create extra space, but if I can do this. I'm going to write it on top. I'm going to write it on top here. Here. So g of 1 over 2 is going to be equals to 1 over 2 squared plus 1 over 2 minus 6 is equals to. This part, guys, g of half, it may take you long to do it, but for those who have Cassio's calculator, you know you can do it as quickly as you can. Eh? Anyone who wants to volunteer and just give us the answer? is our y-axis, this is our x-axis. Oh, and oh, wait. Before you continue, our value for x is minus half, not positive, because we didn't include this negative. It's the equation comes in the form of minus b over 2a. So it's going to be minus 1 over 2 times, and then it's going to be negative, not a positive b. So here, let's put it as minus 1 over 2. So also when you are, whoever who's doing it on a calculator, please substitute minus half, not positive half, because it's going to make a huge difference. Okay, I think, is there anyone doing it, or should I quickly look for a calculator?
Yes, I am doing it. I did get an odd value when I didn't add the negative.
When it was not the negative name. All right, cool.
Mm. Mm. So,
Even
sir,
if it's not a,
Hmm?
it's even if it's not a fraction, whatever value is displayed there, we're gonna work with it.
Oh, okay.
But I believe it's some below, it's probably 6.25 or 6 point something. Negative though, negative 6.25, negative
Yeah,
6.35.
negative six, yeah, negative 6.25. Yeah.
6.25. So it would be somewhere just below, so just somewhere here, negative, just below nyana, so we can call it negative 6.25. And then so that's our turning point, negative half and negative 6.25. Now it's here, and also negative 1 should be somewhere here. So it means our turning point is somewhere here. So this is exactly where the graph should turn. It must not turn where there's a 6. So if we draw our proper graph now, it's gonna come like this. And then it turns there, then it touches the y-axis, and then it goes like that. So it touches minus 3 here. It goes and turn at the turning point. So we must show that the turning point is minus 1 and minus 6.525. And then it goes up there, and then it touches minus 6 at the y-axis. It touches minus 6 here for the y-axis. And then it goes and touches 2 there. So basically, this is the general form of completing the graph. So that graph that we have on the other graph, this one, for them to end up having this curve, is because they had to go through this process. Now, from what we have to reverse the process of a turning point, getting away an intercept, to how they end up coming here. And then we have to find this, what is necessary. So I was just doing this so to be confident when we are here, everyone has something to say because we remember. But now look at this one. Remember I said on this one, okay, you know what? I will hint that part when I get there. But I just want to talk about the turning point only. And get to find the turning point, we say x is equals to minus b over 2a. And then this g of x that we have doesn't have b. It only has ax squared plus 0x plus q, meaning our b is 0. So if we're to say x is equals to minus b of 0 of 2a, it's going to give us 0. So when we say x of 0 would be whatever q is. Hence, the turning point in this one is exactly where x is 0, not on the side, nyana, or this side, nyana. Do you understand what I'm trying to say? hopefully we will catch up as we go. Thing is, if you don't understand something, just write it down. Then we will talk about it on our other lessons when time allows. Not today, another day. The diagram shows, and I don't know, man. Maybe I'm probably withholding you guys. Don't you want to watch the metros, or you don't care?
What?
The metro. You want to watch the metro awards, or you don't care?
What's the metro?
Yeah.
Okay. Okay. Let's just be as fast. But Metro Awards, like any other awards for music. So I get there's some awards. So this one's that specifically for Metro FM. But you know what?
Oh,
Yeah. So I know who it is. There's probably other people who care, others who don't. If I'm withholding you, I swear to God, I'll be done before they start to be. For sure, they're still
oh,
on the. Yeah. Before they start to go deep. I swear, even if we don't really do the whole question, but I will release you guys to be like, okay, and scary, and besides, there's SABC Plus. You can always catch up, but I know you want to watch them fresh, probably. So I won't withhold you longer for those who care. So clearly, Musidi, you like other people who don't have life, ne?
yo, so I'm just trying to make it through the year.
I understand.
Yeah.
I understand. So let's go to the heart of the question then. The diagram below shows g of x is equals to ax squared plus q, and then we have f of x that is equals to mx plus c. We have r and s. What can we say about r and s before we even go to the questions?
Are they not? Is R's coordinates not gonna be like inverse to S coordinates? Or
But besides that, they are the x-intercepts, the way they're
oh,
saying. So r and s are the x-intercepts of G. And G is a parabola. It must have two x-intercepts.
okay.
So R and S are those x-intercepts. And T is the y-intercept. Now, graph F passes through R and T. That information is enough. And then the first question they say to us, we must write down the range of G. The range of G. The range. And then we have range. And we have domain. You know what? Let me close my curtain here, man. Like I feel like since it's dark, the lights are like it's nicer to have the curtains open during the day, but at night I feel like people can see when I'm working, and that's so weird. Okay, now let's talk about a range. I hope I won't have to talk about domain also, but I can cover it in both explanation. So, in your Cartesian plane, you have the y-axis, you have the x-axis, vertical axis, horizontal axis. That's from 0. It goes up. When it goes up until positive infinity going up there. We all know, right? Sure. You know, hearing my voice, I know my voice is dope, but when I hear my own voice, I'm like, hey, now that's okay. Going down. So if it's positive infinity going up, going down, this is negative infinity. Also applies with the word. So for the vertical axis, going up, we start from 0, 2, 3, 4, 500 million, whatever, to infinity. Going down, 0, -1, -2, -2, up until negative infinity. X-axis, going to the right, positive, up until positive infinity. Going this side, we'll go 0, up until negative infinity. So when we talk about the range, we are asking you, where does the graph, like the graph of the function that they are talking about in terms of the range, where does it start along the y-axis and where does it end along the y-axis? The beginning and the end of your graph on the y-axis. There's no, like, I'm not defining a range, but I want you to look at it like that. Say to yourself, range, a range is the beginning. Look at it like that. Never mind my spelling, man. My English is bad. I'm a mathematician. The beginning, the beginning of the graph along the y-axis. Never mind what you see, whatever diagram, whatever graph you may have, if they say to you, determine the range, you focus on the y-axis. You want to know from the y-axis, where does this graph start and where does it end along the y-axis? Where does it start? Where does it end? So such that if I was to give you a graph of a straight line, J, and I say give the domain of this graph, where does it end and where does it start? That's on the thingy. You just look at the graph and then you like, if this graph was to continue going up, where does it, what happened? So you can see, Hore, as this graph keep on going, it keeps on going up, meaning it goes to positive infinity. Even from where it's coming from down, and then it means it's coming from negative infinity. And then we'd say the range of this straight line would be from so this is how we write it though. We say y is an element of, and then you can put it from minus infinity or minus infinity to positive infinity. You can write it like this. Or you can just say y is an element of real numbers. What this means is like y is everywhere. And these two things mean the same thing. I'm going to make another lesson about this specifically. It's just that now we are focusing on that question. So these two things is the same. It's either you say y starts from negative infinity down there where I don't know, because it keeps on going until negative infinity. Mara, as much as it's diagonally, you are not looking at it in terms of the x. You are focusing on when it's going down. You see, also when it's going up, hence is a range. Because a domain is the same as the range. Mara, a domain, we are looking at the x, where does it start and end on the x-axis. So, and luckily for this graph, it would have the same domain and the same range. Because even if you look at it from this angle, if you go like that, that line will keep on expanding like that, meaning its domain would still be X is an element of minus infinity to positive infinity. Mara, now no longer this one, but this one. So I don't want to go deep into this lesson. Don't worry, I'm going to make a specific lesson from it because we're going to end up losing our draft of what we are answering. But with this knowledge, let's go to our graph. Here they say for 1 mark, we must determine the domain of G. Now, the domain of G, it means I must look at G along the y-intercept like that. So on the y-intercept, where does G start? G starts from here. On y only, G starts from here. Because from anything up there, G doesn't exist anymore. Because it tends there. It comes from where it's coming from. It comes from where it's coming from, and then it tends there, and then it goes down. But what I know is up there is positive infinity. Down here is negative infinity. So since I have to determine the range, it means I'm focusing only up and down. Where does G starts and where does it end? So I can see that it starts exactly here where y is 8. And then it goes down. It goes down to negative infinity. Do you see that? So therefore my range will be y is an element of, and then look at how I do it. There's a difference between the open bracket, the curvy bracket and the strong bracket. I don't even know how to call it the strong bracket, but this one. Because this one I'm saying I'm including the 8. So it starts from 8 and then it goes down to negative infinity. No. Actually, Emily, no. Let me read it from down to up. Let me read it from down to up. Let me say, because I need to explain something which I could have explained earlier in terms of what happens when it's concave up and when it's concave down. Do you see that? So it doesn't matter because if it starts from here and it goes down like that, what if I say it is coming up like that and then it stops here? Do you see what I'm trying to say? So we can rather say y is an element of, it starts from negative infinity and then it goes up and then it comes and stops at positive 8. And I would say that's the range. Otherwise, I'm starting to pick up something which makes me feel like I may need to start a lesson with the range and the domain first before we come to this type of a question. Does everyone agree?
Yeah.
Yeah. Because you can either present it like this, or you can say y is less or greater than 8. These two things mean the same thing. Because you are saying, in the first phase, you are saying this graph starts from negative infinity, then it comes up, and then it stops at 8. And then the other one is saying, no, from 8, this graph just go from 8, and then anything less is your range. So that's the range. But the whole concept is that the range is the beginning and the ending of your graph along the y-axis. So on the y-axis, the beginning of the graph was here. The ending, it doesn't end, it goes to infinity, hence the range. Or we can say the beginning is minus infinity, and then it goes and comes and stops at exactly 8. But that's the view of what we see of the graph from then to then. Okay. Before we end this with the worrying of, because this question we're gonna continue it at some point. But before we close it up, there are some things that we can still find, even if we don't have enough information about the domain. So the domain, I've given it. That's how it is. But now the next one, if you have, the moment they say write something, you don't have to calculate. You just write it down. So let's just go through it. So now, if you understood exactly what a domain is without having to go through that explanation, on the question of mathematics, when they say write down, it means it's something which you don't have to calculate. You just have to look at it and write it down. That's why they say you must write it down. So that's why one student would have say, my range is y is less or greater than 8. They would get a mark. And then another student will come and say, no, I want to put it as y is an element of negative infinity up until 8. And then it would stop. But the problem with using infinity when there's 8 in the generation that we have, people think infinity is 8 sleeping.
They think what?
They think an infinity is just 8 sleeping, like 8 sleeping upside down. Like
Oh.
infinity wakes up from a nap, becomes 8, and then at night when 8 is tired, it becomes an infinity. So that's why I don't like such I don't like such expression where you have an infinity and an 8, because people, the way math is so hard, people so it's just one of those. But yeah, I hope for us here, we know the other one is infinity, the other one is 8, because we are professionals, right? All right. Let's do one more last one. The third one. Just to say, before we do the next lesson, it would be about specifically domain and range. And range, I promise. So when we come to this type of questions, we are confident. So I just want to do the one more last one for the sake of finding the values of A and Q. But before we get that, the second one, we have to write the coordinates of R. When they say write down, it means you just write them down. You don't have to calculate. Musiri, you had an idea earlier on. You were cooking. You want to finish the pots.
Oh, that the coordinates of S is just inverse, or like it's R but negative.
This acts more like a mirror. You see, when you look at yourself in your mirror, this image, if it's looking at itself in a mirror on the y-axis, the other side of the image would reflect exactly the very same way, like that. Meaning the distance from here to here will be equals to the distance from here to here, which makes R to be -2 and 0. Is that what you're gonna say, ne? Very good. And then one more last one for 3 marks. This is our closing question for today. We're going to continue with this question paper the other time. It still has other questions that I want us to do, but this one is for the closing for today, just to find the values of A and Q. Anyone who wants to drive this one, and then I just write on my side. When I hold this travel. So step number 1, any volunteer?
Do we not just substitute one of the values of the points given, or
okay, substitute where? Let's start with the fact that our g of x, which has A and Q, our g of x is ax squared plus q. And you know that g of x is the same as y, so I can just write it as y is equals to ax squared plus q. What is the value of q? Since we know that t is the y-intercept.
Is it not 8?
Q will be 8. Does everyone agree that q is 8?
Yes.
And then since you have q, you have to find A. And then to find A, you can't use that point anymore because you've already used it for Q. Either use this one or this one to find A. So if we use S to find A, where there's X will put 2, where there's Y will put 0. So 0 is equals to A 2 squared plus 8. Therefore, minus 8 is equals to 4A. Therefore, divided by 4 divided by 4, therefore A is going to be minus 2, which makes perfect sense. So A is minus 2, B is 8, such that your G of X would be minus 2X plus 8. And it makes sense why it is concave down, because it has a negative A. So remember the story when we have f of x is equals to ax. If A is positive, it will be concave up. But if we have f of x is equals to negative ax, if x is negative, if A is negative, then it's going to be concave down. So that's another story again. That's why I feel like maybe I started this lesson wrong. I just went into it, but also because I didn't do this based on grades. I just took a bit of grade what, and just felt like it's an introduction. But I started with the question paper that I have. I extracted it from a grade 10, but I just knew it's going to assist everyone, because this is not the main part of it. It's just to understand, to be comfortable with questions that come in the form of diagram. Because I repeat, it's always about the diagram, guys. Like from today, like I'm teaching you something behind how people always approach mathematics. We always rush to calculate, and that's not the issue. The issue, reveal that diagram, that graph, because real questions, the one that gives us problems, it's when a diagram is involved. So even if they don't give you a diagram, it is your responsibility to create a diagram. Let me give you an example. In financial mathematics, you're going to have a paragraph like this that complicate things. Mara, if for every line that you read, you create a diagram, which we call it a timeline, and then they tell you, Mang deposited this amount of money every 15th of November. You're like, okay, this is the 15th of November in my time. They're like, 6 months later, they withdrew 500 and left the other amount in the deposit. But then 2 weeks later, they went and borrowed what, like all those nyaga. Mara, when you draft it down ka order, trust me, the moment you approach the question, you can't go wrong, because you have the view of what you're doing. So a good, like, we use mathematics to create real things. It's not about just calculating x, y. So the reason why it's nicer when you work with objects is because those objects are the reason why we are doing the whole thing anyway. So like I said, physics, maths, economics, accounting, geography, questions are about the diagram. The diagram that you have, if you don't understand it, there's no need to even go to even go to try to, because it's like we want to use the questions to unlock the diagram. But no, we use the diagram to unlock the answers from the question. With that being said, we can call it a day today. Enjoy your Metro Awards for those who are watching Metro Awards. For those who don't have a life, enjoy chilling. For those who don't have a life, if you are practicing, the one about life, if you are practicing and you get stuck, I'm still available on the other side. You can send me your question. I can either send you a link or reply through WhatsApp. Ne? Like we are just working, it's freestyle. But tomorrow we'll proceed and get.
Okay.
I'll try to do early during the day tomorrow, so you don't necessarily have to stay Saturday like around this time. So I'll try to. Mara, we know we have different people for Jehovah's Witnesses, ZCC, and everyone who's going to church. When you come back, you'll find us here.
Okay.
Okay.
All right. Enjoy,
Sharp.
guys.
Yeah,
And please
Thank
pray
bye.
for
you.
me.
You too.
All your churches, please pray for me. Tell God I'm still a fan.
Okay.
All right,
Sharp.
yes. Bye.
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 Right. So for those who are watching from YouTube, hey man, it's unfortunate we couldn't finish this question. Like, I felt like we're still gonna finish this question. So you know what you can do? Follow. What do you do? You subscribe, right? You subscribe, press the reminder button, and we're gonna do the other remaining questions. But also you can just see if you can attempt the questions by yourself and comment with the answers on the comment section. But otherwise, we are all together at the end of the day. So look, man, we also, if you want to be part of the people who are on the other side, which I invite on the meeting, like those are our private students. With our private students, we don't count the number of lessons. We just learn throughout the month. So we have a fixed fee to avoid saying 1 hour is 5 rand, 2 hours is 10 rand. We have a fixed fee whereby we just learn throughout the month. But if you want to join us, you can send us a WhatsApp on 081 465 2676. Just WhatsApp us on 081 465 2676. Also, if you have a question, Jay, that you feel you might need us to broadcast your question, you can send the question on the very same number. For a once off, we can do the things for you, but also we can also offer you a free lesson, Jay, just to see how we work things out. So do send the WhatsApp 081 465 2676, because we do simplify things for everyone, because that's what we do. We are here for that all the time.
Simplified, RS are the guys who makes it looks easy. Your number one learning channel.